Hello everyone. This video is a documentation and demonstration of this procedural pipe and cable generator for geometry nodes in Blender 3.0 or above. This geometry nodes group allows you to procedurally generate an array of pipes and/or cables on the surface of any object or between multiple surfaces of an object. The node group allows you to control the radius and material of the pipes or cables, the height and variance of stems, and the density of the generated array. You can also specify the percentage of cables to pipes to create an array of only pipes, only cables, or a mix of both. So I'll run through the options that you have on this geometry nodes group here. The manifold complexity is the first one. This will determine the overall complexity of the generated array. At higher complexities, you are more likely to get stems that are connected to more than one other stem. As you can see here, this stem is connected to two others. Versus at lower complexities, you'll have less of that and might end up with some unused stems depending on your total density. If this value is 100 or close to it, you'll get most of the pipes being generated attached to a single stem, if that can be useful for you. But if not, just keep it lower according to your density. Manifold density will determine the amount of pipes that are generated. If this is too low, you might run into that issue with the unused stems occurring. So make sure that, if you want to avoid that, you can just increase your complexity or increase your density. Density reduction will have more drastic effects on the density of your generated output. So if you want a significantly more dense result, you can reduce this value. Be advised though that lowering this value too far will likely cause a significant strain on your computer. You can also raise this value to produce a less dense mesh, but at a certain value, depending on your density and complexity, you might not get any results. Pipe radius will affect the radius of each of your pipe stems, cables, and generated pipes. Pipe resolution will determine the number of vertices that are used in generating each pipe or cable or pipe stem. Min and max outlet height will determine the spread of heights for your stems. Either of these values can be below 0, so you can get geometry on the outside of your mesh, and the minimum value can be greater than the maximum for a similar effect. Changing the outlet height variance option will change the spread of generated heights of stems, and the master seed will re-roll your generator to produce a different final result. The use cable option can be toggled to enable or disable generating cables in your final output. Be advised though, if you disable the use cables option, the material for the stems will default to cable post material. So if you prefer, you can just change that to whatever you have for your pipe stems. Alternatively, you can keep using cables and decrease the cable percentage all the way to 0, which will give you only pipes. The cable percentage option can also be increased to 100 to generate only cables, and anywhere in between will generate both cables and pipes in your final output. This is weighted a little heavily towards cables, so decreasing it will result in more pipes being generated. Cable seed will give you different results for your cables. Although this does not change the locations of your generated stems, it will re-roll which ones are being used for cables or pipes, so plan accordingly. Cable X, Y, and Z randomization will affect the shape of the cables in those dimensions that you specify. So the cable X randomization value can be used to increase their spread in the X direction. Cable Y can do the same in the Y direction, and Z the same in the Z direction. Cable randomization scale will affect your other randomization values and can be used to generate a more exaggerated shape or a more subdued shape. If you prefer, you can enable restrained cable variance, which will reduce the effects of these randomization values, with the exception of the randomization scale, which can still be used for more significant changes. The use faces option can be used to switch between instancing stems on the vertices of a mesh or on the faces. So right now I have use faces enabled, and I'll go into edit mode on this object, and you can see that each stem is being generated on the face, versus if I disable use faces and we go back into edit mode, you can see that the stems are being placed on the vertices of the mesh. The material fields are fairly self-explanatory. Your pipe material will affect your pipes. The cable material will affect your cables. And the pipe outlet material will determine the material for the pipe stems. And the cable post material will determine the material of the cable stems. Joint material is used for both pipes and cables, so both of them will be using the same material. On the subject of materials, if your density and complexity are high enough, you might get some stems that are connected to both a pipe and a cable. And in that case, it will most likely use the cable material for the cable post material for the stem. And in some situations, you might see that a stem attempts to use both materials. So to avoid this, you can set them both to the same material or just re-roll for a different result. You can also change the cable seed if you like the positioning of the stems but just want to change which materials are being applied. I'll also give a quick demonstration of how you can add this to your own geometry. I'll start by adding a grid so we have several points to work with. And then just go over to Modifier and select Geometry Nodes. Then the Geometry Nodes window, which you can find through this selection, just go into Add and choose Group, Procedural Pipe and Cable Generator. And it will produce the output there. And then just for the sake of demonstration, I'll duplicate this grid and remove the modifier so we can see the original object. And I'll also add a wireframe so you can see where the vertices are. It's also worth noting that these stems are generated aligned to the normals of the face or vertex that they are generated on. So this allows you to instance these stems on curved surfaces. So if I use proportional editing here and curve this plane, you'll see that the stems follow the curvature of the mesh. Now if you want to join two objects together with pipes or cables using this node group, it's fairly simple to do, but you'll need to do a little bit of preparation first. So let's say I want to join this corner of this grid mesh to this lower grid mesh that we were working with earlier. To do that, I would just go into edit mode and select the vertices that I want to work with, duplicate them, and separate. So that's Shift D and then P by default. And then I'll select that new mesh and remove the modifier from the wireframe. So we just have these vertices is all that's in that mesh. And then I will shift click on our geometry nodes object and hit Control J to join. So you can see in edit mode, it has this new geometry included. And then currently the density is pretty low, so I just increase that. And you'll see we'll start getting cables generated on the new geometry as well. And you'll notice that it is aligned in the same direction as it was previously, or it is as this lower mesh is. So to fix that, we can go into edit mode again and select this geometry up here, and then hit Shift N to recalculate normals and change it to inside. So now your cables will be coming off of stems on the inside of the mesh here. And you can increase the complexity if you want to get more connections there. But since that is a smaller area compared to this larger mesh down here, it's going to be primarily generating on this area versus up in this smaller segment up on top. And if you drop the cable percentage down to 0, as you can see here, it will still connect up just fine. So thank you very much for watching. I'll have a link in the description if you want to check this out. If you have any questions or concerns, just leave a comment below and I will do my best to respond to them. And also check the comments too to see if there's been any clarifications or updates or questions answered there as well. So thank you again for watching, and I hope you find this useful.